Hello, science students. We talked a little bit in the last video about waves and the different parts of a wave, including the wavelength, the frequency, and the amplitude. Our goal today is to be able to distinguish between the two main types of waves. There are two major categories of waves: longitudinal waves and transverse waves. Those sound like very scary terms. We're going to try to clear those up today to make it seem significantly less scary. So first, let's look at the definitions, and then we're going to break it down to really understand what those definitions mean. So a longitudinal or compression wave, I think compression wave makes a little bit more sense, but longitudinal is the term that most people stick with. Waves, these are waves whose particle movement is parallel to the movement of the waves. So the movement of the particles in the medium of the wave is parallel to the direction the wave is going. We'll talk about that in a second. Transverse waves are waves whose particle movement is perpendicular. So rather than being parallel, they're perpendicular, so they're moving kind of side to side compared to the movement of the waves. Let's take a quick look at what that means. So first, longitudinal waves. We are going to use the rainbow slinky of science to help demonstrate this. Longitudinal waves, their particle motion is, like we said, parallel or in the same direction as the wave itself. So the wave I'm going to make is going to go from left to right. And if I just pull back a few strands and let go, you can see the springs squeeze and stretch, and it's moving in the same direction as the wave, from left to right, and then bouncing back from right to left. That's all that means. The compression or squishing of that wave is moving in the same direction as the wave itself. Some examples of waves like this are sound waves and seismic P waves, or those earthquake waves you maybe learned about a couple years ago. So sound waves work in the same way, where the air particles are squishing and expanding in a pattern that moves through the air so that we can talk to each other. Let's take a look at transverse waves. Transverse waves are a little bit different. So instead of moving in the same direction, they move perpendicularly. So if I can make this a little bit longer in the view, you can kind of see the particles, instead of compressing this way, are moving up and down. And when they move up and down like this, they are moving perpendicular to the direction of the wave. The wave is still going from left to right or right to left, depending upon your perspective. But the particles in the slinky themselves are moving up and down. If I were to mark or pick one spot on this, let's pick this spot right here where it's turning from purple to pink, and we just stare at that one spot as best we can. You can see that is just moving up and down, but it isn't really moving left to right. The wave itself is moving left to right, but the particles in the medium or in the slinky are moving up and down. Several examples of these. So water waves, when you see that water wave from the side, or ripples in a pond, very similar. Electromagnetic waves, which include light waves, are also transverse waves. Vibrations in a string move in similar fashion, and seismic S waves are also a transverse wave. Okay, so two types of waves, longitudinal and transverse, and we showed you some examples. Thanks for watching.